Good afternoon, everybody. Thank you for joining this session today. My name is Joe Healy. I'm a consultant within the Worldwide Public Sector Professional Services team at AWS, based in Herndon, Virginia. And today, I'm going to go over with you on some different options that you have. You may or may not be available. You may not know the depth of them, but different services that you can potentially leverage at AWS to use it as a data platform. Before, there's different constraints that different companies and organizations run into, whether in their existing infrastructure or potentially their perception of leveraging something like a public cloud like AWS. These deal with the types, the volume, the velocity, the variety of data that you have within your architectures themselves. It's overwhelming. You're very constrained as far as the resources that you have to address that, or more importantly, you may not have the bandwidth to actually leverage something external to you to actually offload that and process the data there if you need to. It's very expensive as well, either from an existing infrastructure that you want to allocate to meet your new demands, or you may feel that I've paid for what I have right now. Why do I need to pay more to do something somewhere else? You may have very unique security requirements for the data that you have. That may be a reason why you've kept it on premise. Or public cloud, or the ability of it, is viewed as being way too complicated for how I do my operations. As it says in the bottom, it's not always as difficult as you may perceive the challenge to be, or the constraint. Looking at the available services and capabilities that AWS and our partners provide, we're able to address many or all of these constraints. Obviously, it's for you to determine that. But starting with security and compliance, the visibility of the security controls and the governance of them is staggering, what you can do within something like AWS. And the processes and procedures that we have in place to meet those requirements have been validated by third-party assessors and measured against many of the common industry compliance standards out there for verification. The infrastructure itself, we have 12 public regions throughout the world that you can choose to deploy your infrastructure in. Each one of those regions has at least 2 availability zones within it, which are geographically separated, 1 or more data centers per availability zone. So you're able to build in some highly available infrastructures without really doing too much at all. On top of that, we have 56 edge locations throughout the world. So being able to bring the connections and the actual data closer to your users improves the experience. Support, through the account management team that you can work with at AWS, dealing with whoever your support is, your account manager, solution architect, professional services if you need to it. They're going to be there for the journey, your individual journey, as far as going from your known state to that defined target state and helping you get there. But more importantly, the partner network's there as well to fill a lot of the gaps in that we have. From a feature perspective, the ISVs are developing SaaS solutions, or being able to deploy them through the marketplace, or through management consulting, or managed services. They're able to kind of help you with meeting your individual requirements. And it really comes down to the actual services themselves. The services are driven by customer requirements, period. Everything comes from customer requests and requirements. So they're constantly evolving, the existing ones that we have, and new ones are coming out to meet your requirements. So you always want to keep up to date as far as what's available. Due to the limited time that we have, obviously, to cover all the services that we have, I think we can narrow them down into 4 different phases, if you will, of dealing with the data itself. The first is kind of the movement, or moving that data into AWS, getting it from point A to point B. Obviously, the quantity of data and the time frames dictate and add to the complexity of your situation. Then where do you store it? We have different types of classes of storage they can use within AWS to meet your individual requirements themselves. The processing of the data, obviously that's where you're going to get the insight and information of the data itself. You have unique requirements for all the data that you have, and we have different tools that you can leverage to kind of get that insight. And obviously the insight that you're getting from your data is useless unless you're able to provide it to your users. We have some great tools that can help you from the actual analytics capability and doing the correlation of it, but also the delivery of that data as well. So starting with the movement of the data itself. I'm going to go over kind of talking about what is Snowball. It's a new capability that we released for actually doing payload-based data transfer to and from AWS. S3 transfer acceleration. It's a new capability added to AWS as far as if you use anything like a WAN optimization right now, this is going to be a very interesting service for you to look at. And obviously there's Direct Connect. So you're going from different stages of movement of the data for meet different requirements. So starting with Snowball, the import-export service has been around for some time. Prior to Snowball, it was the customer's responsibility to buy their own devices to actually do the transfer of the data to and from. These came in with different requirements of eSATA, different USB connection methods. So the speed of transfer was widely variant based on what you had and based on what your requirements were. And you were limited on the actual size of the transfer for each job at 16 terabytes. So to help streamline this, Snowball was developed. And Snowball itself is our device. You don't buy anything. You actually go through a workflow and actually have the device shipped to you. It comes in a very large case. It's probably like a small suitcase size basically right now, so it's highly rugged. It's able to deal with weather. It's able to deal with bouncing around. It's very tamper resistant. It has all the capabilities inside to detect anything. And it's also part of a workflow. That there's an e-ink, think of it like a Kindle, that has all the address labels baked into it based on the information that you inputted into the job itself. And it's highly secure. All the data is encrypted on the device to and from. Recently, we increased the actual size of the device itself. Started at 50 terabyte per device. Now it's up to 80 terabyte. And we've added the geographic regions where you can actually send data to and retrieve data from with the Snowball device. So it includes GovCloud within the US. When you start thinking about how long does it take to move, in this case, 50 terabytes of data, there's a lot of variables that come into play. Obviously, you have to have some type of connectivity to S3. What is your connection like? How much control and how much utilization can you use on that line? So looking at this, with a Snowball device itself, it comes with a 10 gigabit interface. When you start comparing that versus what you can get from your ISP connection, it may or may not be a good thing to consider using. So once you start looking at the utilization of that line and how long it takes to transfer that data, where it's measured in days usually versus hours or minutes. Where it really gets interesting is when you start increasing the amount of data that you actually need to move from a payload perspective. In this example, you have 50 terabytes, or 250 terabytes. You can do a parallelization of the Snowball devices themselves and get multiple of them during one job versus having to serially or try to parallelize that data transfer up to S3 from your own infrastructure. Again, you're talking into the tens of days generally to get that done over traditional lines, basically. So it starts getting very interesting in these types of models the more data that you're adding to it. As I mentioned before, the security is paramount. All data is encrypted to the device itself using keys from your KMS that are never stored on the device itself. It's the chain of custody command in the workflow, so you know exactly where it is and where it's supposed to be in that steps of the workflow. And I mentioned before the e-ink, it determines where it's shipped to you and then back to the actual AWS region itself that you're doing the data to. So there's nothing for you to manage. If it is tampered, you'll be alerted. And it's able to detect that. And after the actual device has been offloaded, it is wiped out to NIST standards 800-88 to do the data removal on the device itself. So they are reused. Talking to cost, $200 per instantiation of each device. For 50 terabyte, $250 for 80 terabyte. And you get a 10-day window of using that device, so you can count for the actual transfer to and from and the actual transfer of the data onto the device itself. There's a small charge for each day, obviously. The data out is a normal S3 data out charge. It's nothing unique to Snowball. Moving on to S3 transfer acceleration. Maybe that doesn't meet your requirements. Maybe you can't bring an external device into your network. Maybe you just don't have the logistics of many teams being involved with the transfer and you have a smaller window to actually do a migration. S3 transfer acceleration may meet your requirements, especially if you use any type of WAN optimization right now. You know, troubleshooting and optimizing connections over the internet can be complicated because many of the different hops to your destination from your source are completely out of your control. So you have highly variant connections as far as transferring data there. Where transfer acceleration comes in is it is going to leverage our edge locations. As I mentioned, we have 56 of them throughout the world. And it's going to give a highly optimized connection from that edge location back to the region where you're bucketed in using proxy servers, basically, as well. So you're able to get a much better and more consistent and generally higher, much better experience as far as transferring data to your S3 bucket or from it as well. You know, typically, you know, it's 50 to 400% faster. Obviously, your network comes into play here and your connection to it. So the further away you get, the distance between your source and your target, that's where you're going to achieve the greatest results with this. If you're within Northern Virginia office and you're copying to an S3 bucket within US East, you're probably not going to get any benefit from this. And you won't be charged for that. That's the benefit of this as well. If there's no benefit to using this versus doing a straight S3 copy, there's no upcharge at all. It's going to use that natively. But if you're copying across country or across continents or within, obviously within large continents, you're going to be able to achieve a very good performance with this tool. And you're just leveraging the same endpoints. You're not putting any software on your service, you don't have to use a special client. You don't need to use a special API. All you're doing is changing the actual endpoint where you're sending it to. Well, I'll show you that in a second. So it's over HTTPS. There's no firewall exceptions you have to do. So it's a very seamless transfer of the data to your S3 bucket. So it's going to find the closest edge location to where you are, and it's going to send you there, and then that connection from that edge location back to the S3 bucket is highly optimized over our backbone. So at the request, Route 53 comes into play whether you're using Route 53 or not. That's going to determine which edge location to send you to based on an anycast and latency-based routing, basically. And from that edge location back to the region, there's going to be kind of a managed proxy layer that you don't have any visibility into or management of. It's just in between the edge location S3. That was always, with WAN optimization copying to S3, you would have to build your own EC2 layer and get that optimized connection to your region of choice, and then from there you dump it into S3. This is doing something similar, but you're not managing or paying for that layer. As I mentioned before, this really becomes an interesting option when the further away you are, or the more distance there is between your source and the target S3 bucket. Just because of what comes into play when you're dealing with distance and latency and connection optimizations over long distances. If you use S3 in the console, all you do is on the right in the properties of the bucket itself is a simple checkbox to enable it. And behind the scenes, a CNAME and a CloudFront distribution is going to be created for that bucket itself. And you simply use that as your endpoint for transfer data to and from. We do have a demonstration tool that you can test it out yourself from your own individual location, where you can do sample transfers from your connection, and it will do it to buckets throughout the world to show you what it looks like from an S3, directly to S3 standpoint, and from using the transfer acceleration tool. So you can get an idea of what it is that I can expect if I use this service. Because obviously, you need to justify it. There is a charge for it. It's 4 cents a gigabyte to use this service, whether you're sending data in or sending data out. And that's a little bit of a different model for things that AWS are sending data to S3. Usually all data ingestion is wiped out. There's no charge for that. Usually it's the extraction of data outside of that S3 bucket itself. This is a little bit different. So you need to think about what are your use cases for getting data into AWS or out of AWS, and how quickly do I need to use it? Or am I replacing another process, whether it's some WAM optimization tool, which you may be able to get away from, or is it the time that you need it? So you just need to measure what your own specific requirements are. And then we get to Direct Connect itself. This is where you need to have a lot more control and governance and assurance of the path your data is taking, either to a private within your VPC or to a public service within AWS itself. This is where you get a dedicated connection lines, to that, like I mentioned before. You get faster connectivity, but more importantly, you get more consistent. This is where you need the consistency. You can't have any jitter or wide variance of latency between your connections. And you can do it from a private connection from your on-premise directly to your VPC or VPCs. So you're never going on the public network at all. And there's a lower, if you're doing a lot of data extraction from S3, this is where you're really going to benefit from using something like Direct Connect, because the data transfer charges are substantially lower. So right now, we have 12 regions throughout the US. There's 28 Direct Connect locations. They're generally within within a region, AWS region, but sometimes they're not. But you can see where they are right now, but this is always changing. More specifically, within the US, we have 10. So we have four regions which are quote unquote publicly accessible. The GovCloud's a little bit different, but it's still a publicly accessible region. So you can see why all these lines and these colors. Well, there's a one-to-one mapping between a Direct Connect location and the private connectivity you need to your resources within a specific EC2 region. So for example, Equinix in Dallas, you're only able to get private connectivity to the US East region. You're not able to get private connectivity directly to the QuickSight, to Northern California or Oregon from that location. On the converse, there's a one-to-many relationship from each Direct Connect location to the public resources within a region, specifically within the US. So that same region within Equinix, if you have a public interface, you can route directly to every single US region, including GovCloud. So it enables a lot of different connectivity options as far as how you can connect from one location to another through that Direct Connect location. So let's move on to storage of the data itself. We're going to limit it to 2 options here with S3, kind of going over some of the different storage options, storage classes that S3 has, which you may or may not be familiar with. And also with EBS, there's been a newer release to a volume type in there, which is interesting for specific use cases, which may be of interest to you. So within S3, there's 4 classes of storage for each object that you have in S3. There's standard, which is what you think of, 11 nines of durability and all that. There's reduced redundancy. There's S3 standard infrequent access and Glacier. Each one has their availability, durability, and accessibility restrictions or requirements. We're just going to focus on 3 for now. S3 at the top is just the standard, if you will. So the way you can really think about these is the actual how warm or hot do I need this data? how accessible do I need to get this when I need it? Because the hotter it is, the more you're going to pay for it. The colder it is, the less you're going to pay, but the less accessible it's going to be. So you need to figure out, where does my data, or this data within this life cycle, where does it fit within this? Because if you're able to map out the hierarchy of your data from a life cycle perspective, you're able to substantially lower the cost of the storage of the data. And you can leverage things like lifecycle policies, which can be just represented based on your business rules of that data, versus people going in and manually moving this data between the different stages or different buckets. You can use lifecycle policies to do this for you. When I mentioned pricing, so this is US standard or US West 2 pricing. So for standard S3 objects, it's 3 cents a gigabyte. There's no minimum limit as to the size of the file has to be, or the amount of days you need to keep it in that storage class. As you move into standard and frequent access, the price goes down. It's 1.25 cents for each object, for each gigabyte for that object. But you start seeing where the complexity starts coming in as far as what you need to understand as far as what that data needs to be, who's using that data, how does it need to be used, and some of the different characteristics of it. You see the greater than or equal to 128K. That means each object, whether it's less than that or equal to that, you're getting charged 128K for each object itself. The greater than 30 days, greater than equal to 30 days. If you have an object in that storage class and you delete it in 2 days, you're getting charged for 30 days for that object. So you need to understand that, but that's where you can guardrail yourself using lifecycle policies, so you're actually using your policies to rotate that data through it. Then you go down to cold data, which is the Glacier class. So that's even cheaper. You have retrieval rates, but the SLA is the kicker there. Each time you need that object, you're going to go through a 3 to 5 hour SLA to actually initiate the transfer process of that object. Where S3 is different is you might not know exactly when you need that data, but you know when you need it immediately, just like it was a standard object. That's when you're going to use SIA. You know it's not active, but you know it's not cold, but you want it available when you need it. Now moving into Elastic Block Store. Traditionally, the volumes are measured in IOPS, input, output. This is not measured in that. This is measured in throughput. So it's generally for sequential workloads, basically, is how you can think about it. So these are throughput optimized volumes that came out recently that really opened the door for some specific workloads. As I mentioned before, it's not measured in IOPS. It's measured in the throughput. And there's ST1 or ST2. ST1 is more of your hot. SC1 is more of your cold, if you will. And for those of you familiar with EC2 and working with T2 instances, you understand the credit model, where depending on the instance type that you have a baseline level of performance for that instance. But depending on the, obviously, also depending on the instance type itself, you get a certain amount of credits that you can build up that you can burst to use for a short period of time, and then the credits are depleted as you're using that burst. So it allows you to work with bursty workloads, so you don't need to pay for all the performance that you may need all the time. This works the exact same way, but in a little bit of a different way. So you have the concept of, depending on the size of the volume that you create and the type of volume, whether SC1 or SC2, you get a baseline level of throughput that you can achieve with that volume. And as you add more to it from a terabyte perspective, you accrue more and more credits per second against that volume. So you're able to burst the throughput on those volumes as you need it, basically. So if you're dealing with workloads that traditionally you're using ephemeral disk for, some type of Hadoop type of thing, EMR, potentially Splunk workloads, where you're using large amounts of local storage, ephemeral storage, to get the benefit of using local storage to get the throughput, but you're not paying for the storage itself. But the problem with that is if you need a ton of storage that locally to meet your requirements, oops. Here we go. You guys getting a little bit of preview here. But if you needed a ton of storage to deploy your clusters, just to get the storage amount, you may be over. All right. All right. Oh, you're doing it. Okay. So you're playing me. Let's go backward. A couple more. That's it. One more up. Yep. So going back to like a Hadoop cluster, you're deploying, if you need a ton of local storage to do your processing on, you have to get really high in the instance class, because it's all depends on the instance. Not all instance classes have ephemeral storage, but those that do, it ramps up as you get it higher into the instance class itself. So to get the local storage requirements that you need, you may be over-provisioning the actual instance type that you need to get the storage that you need. Where this is going to benefit you is instead of using the ephemeral storage, you potentially could use these volume types. One, you're going to get the size of the volumes that you need to do your processing on. You're going to leverage snapshotting and other capabilities to get the RPO and the recovery objectives that you need to meet without having to do a lot of replication between the nodes to deal with the ephemeral storage restrictions. But also, you're going to be able to right-size the actual EC2 instance requirements from a CPU and resource perspective. So instead of over-provisioning your EC2 to get this local storage, you're going to right-size the EC2 and allocate these volumes to meet your storage requirements. And the way the credits work is they penalize random I/O. You're measured against 1 megabyte credits each time you do a request. So if you do a random I/O, it's one or equal to or less than 1 megabyte, you're getting a credit used for that. If it's a sequential request, it's going to queue those up from a credit perspective to 1 megabyte chunks as far as a credit standpoint. So you can still use them for random I/O, but you're going to deplete your credits really quickly. So again, understand your workloads. I'm sorry, go ahead. And pricing, you get a substantial price break for these as well. You're basically reaching S3 territory for some of these use cases, basically having it directly attached to directly accessible to your instances themselves. So the price performance is very good for the right workloads. You need to understand if it's IOPS based or throughput based, and if it's random I/O versus sequential. Next one. So moving on to process. Let's go one more. There's many more services within AWS, obviously, to do processing. I just want to focus on a few right here related to RDS. Talk a little bit about the migration service and Kinesis. So the relational database service, probably you're familiar with this, but RDMS is a very common component for all architectures. Go one more. Using RDS, you're able to offload a lot of the operational administrative tasks that are part of managing a database. Doing things like the actual provisioning and installation, applying patches, doing backups, potentially doing multi-AZ replication, things like that. Those vary in complexity, but they also vary in as far as the value that they add to you as well. So within RDS, we have a lot of different engines that you can leverage within the same RDS service itself, whether it's the commercial Oracles and SQL servers of the world, or moving into more of the open source with MySQL, Postgres, and a Maria database. And also there's a newer variant that's ours, basically. It's called Aurora, and that's all intents and purposes, it's MySQL compatible, basically, but it's very performant, very available, and you can get very large databases as well. So with that comes a trade-off. Anytime you're doing a managed service, there's a trade-off as far as the demarcation point is where you give up control. How specific is your requirements for that database itself that you're running? You don't have access to the host operating system. You can't log into it. You may or may not have some options that you're dependent upon from your traditional, your on-premise, or even EC2-based database that may preclude you from using it. The size of the database that you may need may be too big for RDS. There's benefits that you need to weigh as well, as far as the operational burden, the administrative tasks, patching, and doing things like HA. So even as simple as something as complex as doing synchronous replication to a standby database is not an easy thing to do, and it can be very expensive as well, depending on the platform that you're using. By simple checkbox within RDS, you can enable this and have a standby database deployed within a standby, within another AZ within your VPC, and the synchronous replication is handled automatically. In the event there is a failure, the database is cut over automatically to the standby, which is promoted, and all the traffic is sent there. No change needed to your application because the same endpoint is used for the database itself. Obviously, depending on how brittle the application is as far as how it handles connections interruptions, you may need to take some steps there. But the actual connections to the database and how you get there are seamlessly handled for you. So that's a very high value option that's available from using RDS. But how do you get to RDS? You know, it is a managed service. You don't have access to the OS. How do you get your data in? Historically, that hasn't been a very easy thing to do. You know, if you work with Oracle, you have all these RMAN backups, but they're completely useless with RMAN. You can't get them in there. How do you, I mean, you're just very limited as far as the data that you can get, how you bring your data into something like RDS. Until something like the database migration service came along, latter part of last year. This is allowing you to transfer and set up replication between your target systems, which can be on-premise based databases, or it can be EC2-based databases, or it can be an RDS database. It's heterogeneous as far as where you're coming from, and the target can be the same thing, but more importantly, it can be RDS. So you're able to do, you know, those payload and the actual and the replication of the changes, which are captured from the source into that target database. It's a very interesting service that's been available for you. And you're able to work with all the platforms within RDS right now, whether source or target. Something you don't see Redshift on there. That should be coming, you know, the near-term roadmap. That'll be coming. So that'll enable a lot of easy transfers from your transactional to your warehousing, basically. Now we'll get into Kinesis. This is data streaming, basically. So any of you using things like Kafka or other types of capabilities for providing this type of service, this is something that's going to be of interest to you. You know, this is a simple way of deploying that infrastructure to create those streams to ingest all that data coming from multiple services, multiple types of data that you can run your analytics and processing against. You know, it's in that near real-time latency of the data from being received to where it's actually usable. And you pay as you go, like many of the services that we have. One more. So there's three options within Kinesis. Two of them are available now. One is coming soon. The first is the actual Kinesis streams itself, where you can create a stream that you use almost basically think of it like an endpoint to send data to, but you have a high degree of configurability and development access against the performance of and the capability of that stream itself. Firehose is a newer capability within Kinesis. This is where you have less need to customize the data itself as far as the processing of the data and the speed that you need it. It's generally measured in the latency of a Kinesis stream is in the sub-seconds range. Firehose, you're going to be in the sub-60 seconds, right? So depending on the requirements of where you need your data and what you need to do with it, you're going to have a different option to use. And the last one is analytics. That's going to allow you to run SQL-like queries against the data as it's streaming in. So that's going to be a very, very powerful value add to do inline analytics against the data that's coming in. So looking at a Kinesis stream, you can go from many different types of sources that you develop through SDKs or producer libraries or using common tools like Log4j or Flume or other ones that you can use to send to your streams itself, which can then be picked up by your processing engines, whether they are hosted either on EC2 or running like MapReduce or other types of capabilities. Even Lambda could be event-based and running the process and get them in line. And you can also write it to S3 for persistence. So you can use one or many of these with a single stream. Next slide. Firehose, similar concept. It's a way of getting data in from a common endpoint. So you create a Firehose stream, and you're able to send data to S3, Redshift, and Elasticsearch, managed Elasticsearch right now. You can send it to one of those services, two of them, or all three. It doesn't. You're not limited as far as it's a one-to-one, or you need a separate stream for each destination I need. So again, this is for those workloads which are less time sensitive, but you just needed to get there to do the processing within a reasonable amount of time. Next slide. So now let's get into the actual delivery of the data itself. A few services which are interesting are QuickSight, which is our soon-to-be released, it's in preview mode right now, managed business intelligence service. The next is Amazon Elasticsearch service. So anyone running an Elk stack right now, this is going to be potentially of interest to you. And also CloudFront. This is our content delivery capability within it, but it's used by many other services as well, or more capabilities. So next slide. So again, like I mentioned, QuickSight. This is a service that's, it's in preview right now. You can request access to it and try it out yourself. It's just a very performant, very cheap business intelligence service. Next slide. Data is, the questions, your data is just full of information that you need to ask the questions to get it out of that. And there's different ways you can represent that data which add more value. And it's very difficult to determine what those are or manage the infrastructure to do that. Next slide. The tools potentially are very, very expensive. They take a long time to actually implement. That's obviously changing as more SaaS platforms come on board. You're able to leverage those more, but again, the cost is the important one, is how much does it cost for me to get this capability? Next slide. So looking at it, you're able to represent your data, and regardless of where that data is, and we'll cover that shortly, in different graphs or analyses within there, and you have a common platform for it using mobile devices or a web interface, basically. And all of this is exposed through an API, and this API is accessible through the clients themselves, but also your traditional tools as well. They can interface with this to leverage some of the benefits of it. You might be coming from somewhere where you can't leave that platform, but you may be able to attain some of the benefits of using something like QuickSight by exposing it to the application itself. And within there, you have many different data formats you're able to interface with, whether native to AWS or you're running third-party tools through some type of connection, whether JDBC, ODBC, or text files. Next slide, please. So the sources themselves, we support natively from launch many of the storage and processing formats that are available within AWS natively. So you're talking EMRs, the RDS, the Kinesis, S3, but you can either query text files, and other third-party methods to access your data. So it's extremely flexible, and it's a one-to-many. You can access all of them within your analyses. Next slide, please. Some of the secret sauce within what really differentiates QuickSight from a traditional BI engine is referred to as SPICE. It's an acronym for a super fast, parallel, in-memory calculation engine. I'm not joking. So, by looking at it, it's a highly optimized in-memory analysis engine that you're able to query against. You're able to get very, very fast results. So this is something that may or may not be interesting to integrate with your existing tools, just to test it out. just to see how it works and potentially replace them. But that's up to you. But it does have the flexibility. It's not a closed system at all. Next step. Elasticsearch. So many customers are running their own, what's referred to as an ELK stack. That's an acronym as well for Elasticsearch, Logstash, and Kibana. So basically, Elasticsearch component is just a way of indexing a lot of disparate data and try to get some information against that. The Logstash is a way of sending data, collecting data and sending it to Elasticsearch, and Kibana is a way of doing visualization and queries against that data. So we came out with this service the latter part of last year to kind of help you deploy and manage those clusters that you build for Elasticsearch. There's a lot of moving pieces to an Elasticsearch cluster, especially as you start scaling this. And this is decoupling a lot of that administrative work from you, but you're still getting a lot of the benefit. It is native Elasticsearch and the libraries for it, so it's highly compatible from how you do things right now. Next slide, please. So, but it's built into our ecosystem, if you will. So from a security perspective, you use an IAM, it's meeting with your policies there. From CloudWatch, you're able to integrate with your own metrics and the auditing of those. Leveraging things like CloudTrail, you're able to see who is accessing, or more importantly, who is administering and changing the parameters on my cluster itself. And it's able to interface natively with a lot of our services or log aggregation services like CloudWatch Logs. So the Logstash that I mentioned earlier, you could replace that with something like CloudWatch Logs. It would be a different acronym now, but that's basically serving a similar purpose where you're able to do the collection and then using a native connector, if you will, you can send that data to your indices within Elasticsearch. Next slide, please. So this is what Kibana provides. This is a visualization tool. So if you're using something like Sumo Logic or Splunk, you get the idea. They add a tremendous amount of value and insight into your data, and as we add more features, they iterate on them to lessen the burden on you to get information from all those copies of data that you're bringing into the service itself. You could do the same thing within Elasticsearch, but the burden's on you to actually come up with those insights. So that's where the value that they're adding is they're iterating on our capabilities for you. So it's how much do you want to pay for that and how much work do you want to invest in that. That's what something like Elasticsearch can add value to you. Next slide. Now finally, I'm going to go over CloudFront, which is our content delivery network. And traditionally you think of content delivery as just I have a bunch of static content and I want to offload that from my web servers and then bring it as close as possible to my users. Great use case, one that CloudFront meets very, very well, and especially as we add more and more edge locations throughout the world. We have 56 right now, and that's ever growing as we evolve. Next slide, please. So this is a brief view of where it is. It might be a little bit out of date because things are added over time, but you get the idea. Most populous areas are going to have one or more edge location, but it changes over time. Next slide, please. So basically, as CloudFront works by you create a distribution, and in this case, we have a web distribution for our web application. You can do streaming video as well, type of distributions. So the way the distributions work is they need an origin of information. And it doesn't just have to be one. I mean, your web applications have different sources of content. You could have dynamic content coming from an application fronted by an ELB. You can have static content in an S3 bucket, but they have their own distinct patterns of where that data is stored within your URLs. If you can distinguish between that, you can easily set up multiple origin filtering within your distributions themselves. So the common entry point for your application can go to one or more origins of data, depending on where it is and within that filter itself. So that content the user is going to hit the edge location, which is much, much closer to them. So the latency and distribution of it's much better user experience. Next slide, please. One thing I want to touch upon a little bit is the capabilities that are being added within CloudFront is growing. One of those is web application firewall. So from a managed service perspective, you're able to leverage something like a WAF in line with your CloudFront distributions handled at an edge location, not touching your infrastructure within your EC2 or even on-premise. So the benefit here is you're able to do SQL injection, cross-site scripting, all those types of checks you can't do with traditional tools. So you're able to do it at a managed service level within something like a WAF, but it's at a content distribution level. Next slide. And this is just another view of that, going to multiple origins, and then what you can do. You can validate your traffic even before it touches your infrastructure at all. So next slide. So that's basically, I ran over a little bit, I apologize, but I just wanted to give you a little bit of exposure to some of the capabilities that are available within AWS from a data platform perspective. Obviously, there's a lot more that we provide for each of those different phases. We have extensive documentation. You have interface with your service team from an account manager, SA, or even ProServe, or with your trusted partners to kind of dive into it more. But just thank you again for your time today.